All right, welcome back. So we've got two more to do from section 4.7 that was not on my original notes, number 14 and then number 17. So let's get going on 14. Now I know if you already watched the first video, we did number 15 already, which is actually, one step harder than this one because this one is only asking us for one antiderivative, and I just went through and showed you how to do the one with two. So 14 should be a good quick review for that. All right, so we're given the function 2x to the 7th minus 4x cubed, and we are asked to find f, capital F of x. So remember the notation, antiderivative uses a capital F if the function they give you is the lowercase f, okay? And then they're giving us this initial condition that f of 0, so this is the antiderivative, is 19, okay? So that's going to help us find that c value. All right, so here's the function, so let's do the antiderivative. So in this problem, it will be capital F of x, okay? So remember the rule for the polynomials for each term is to add 1 to the exponent and divide by that number. So the antiderivative of 2x to the 7th will be 2x to the 8th over 8 minus the antiderivative for 4x cubed would be 4x to the 4th over 4. Right, so add 1 to each of those. And then don't forget, we always have to add in that constant because we don't know what that is for any function. And again, on this one, we are going to know what it is because they gave us that initial condition. All right, so let's go ahead and simplify that before we figure out what c is. So this would be 1/4 x to the 8th minus x to the 4th plus c, right? All right, so now that we have our antiderivative, we're going to plug in the initial condition. So x is 0, y is 19. So 19 equals 1/4 0 to the 8th minus 0 to the 4th plus c. So this one's kind of easy to do because 0 to the 8th is 0 times 1/4 is 0. 0 to the 4th is 0, so all we have on this side is 0 minus 0 plus c, which is c. So c is 19. So our antiderivative, completely known to us now, is 1/4 x to the 8th minus x to the 4th plus 19. Okay, so that's the differences with these, which we talked about on the first video. If you're not given any initial condition, then your answer would have just been this with the plus c in there. Some of the problems will give you some conditions, and then you can figure out what c is. Okay? All right. So the last one we're going to do together is number 17, and this is a good problem, kind of putting everything together with the velocity and acceleration, because remember, those are going to be antiderivatives going backwards. So if you're starting with an acceleration problem, you can figure out the velocity and then the position, because now we know how to do antiderivatives, okay? All right, so looking at number 17, it says a stone is thrown straight down from the edge of a roof 720 feet above the ground at a speed of 5 feet per second. Given that the acceleration due to gravity is negative 32 feet per second squared, how high is the stone 2 seconds later? Okay, so we have some initial information up here. So let's see what that looks like. Okay, so I'm going to draw a quick little picture. So we are on, or somebody is on top of a roof. Okay, so here's the ground. Somebody's up here, and they throw the stone down, right? So somebody's throwing the stone down. All right, so what are some of the initial conditions that we are given? Okay, first initial condition we're given is that we know that this person is 725 feet above the ground. So from here to here is 725. Okay, that's an initial condition. Okay, so that's the first thing we know. So again, remember what that is. That's this person's position, right? He is 725 feet above the ground when this process begins. So when the time is 0. So remember, we're going to be using t for our variable. So the initial condition is at time 0, the position of this person is 725. Well, not the person, the stone, okay? So we're looking at the position of the stone. So if the person had it in their hand at time 0, then the stone, okay, the position of the stone is 725 feet above the ground. All right, then the other initial condition is that he throws the stone down, so it's going down at a speed of 5 feet per second, okay? So this stone is heading downward, so that means -5 feet per second is another initial condition. Okay, it's another condition that was given to us initially. So that means, remember, feet per second is velocity. So that means the velocity at time 0 would be -5. Okay, so he didn't throw it very hard if the speed at the beginning was 5 feet per second. So basically just tossed it. Okay, all right, so there's our initial step. So we have some initial settings, which is going to help us remember find those C values when we do the antiderivative. All right, now, what makes the stone go faster and faster when it's coming down, right? When we come down, when anything's falling, gravity will make this stone go faster and faster or speed it up, okay? So they're giving you the acceleration function, -32 feet per second squared. So the acceleration is -32. Okay? That is a function. That is the basic function for acceleration. All right, so if we have the acceleration function, we can find the antiderivative of that, which remember would be velocity. Okay, remember with our problems from chapter 2, we started with position. The derivative of position was velocity, and the derivative of velocity was acceleration. So now we're going to go backwards. So we're going to do antiderivatives. So the antiderivative of acceleration will be this. Antiderivative of this will be this. Okay, so we're just going to do it backwards. All right, so let's find the velocity function. So let's do the derivative, the antiderivative of -32, okay, which means that's the constant. So we just add t to it, right? Usually x, but we're doing t, and then plus c. Okay, so again, if you take the derivative of this, that would be -32, right? So that's its derivative. So this is the antiderivative. Now we're going to use our initial condition for velocity to find c. So when t is 0, the velocity is -5. 32, 0, right? So we end up with c equaling -5. So our velocity function is -32t minus 5. Okay. All right, so now we have acceleration. Now we have the velocity. Okay. And how high is the stone 2 seconds later? How high? That's position. So I got to find the position equation now. So we're going to do the antiderivative again. All right, so add 1 and divide by it. So this will be -32t squared divided by 2. This is your constant, so -5t plus c. All right, we're going to simplify that. -16t squared minus 5t plus c. Okay, all right. Now we can find c because we know this initial condition for position, when time was 0, the position was 725. So 725 equals -16 times 0 squared minus 5 times 0 plus c. So we'll agree that c is 725. So our position function will be -16t squared minus 5t plus 725. All right, so now we have all of our functions. So now we can just answer all the questions. We haven't even answered part A yet, but we needed to do all that because we did need the position. So now the question is asking you, how high is the stone 2 seconds later? So now all we have to do is put in 2 and we can figure out the answer to part A. Okay, so I'm going to come up here for part A and do S of 2. So that would be negative 16 times 2 squared minus 5 times 2 plus 725. Okay, so we're just plugging in 2 to find the position of this stone. Okay, so 2 squared is 4 times negative 16, that's negative 64 minus 10 plus 725. So the position at 2 seconds, okay, negative 64 minus 10 is negative 74 plus 725, that gives me 651 feet. Okay. So after 2 seconds, we're down here somewhere at 651 feet. Okay, so that's part A. All right, so a lot of work to be done, but now we have all the functions, so we should be able to just find these answers now. All right, so part B says, at what time does the stone hit the ground? At what time is the stone here? Okay, at what time does the stone hit the ground? Okay, so when it hits the ground, okay, so that's when is the time. So we will do when does the position equal 0, right? The position when it hits the ground will be 0. Remember, the position when we started was 725. The position at 2 seconds was 651. So the position at what time is 0, right? 0 feet off the ground. So that's what we're getting ready to do. Okay, so we need to set the position equal to 0. That's 5t. Okay. All right, I can't factor that, so I'm going to use the quadratic formula. So not x equals, but t would equal, right, negative b plus or minus square root b squared minus 4ac all over 2a. Okay, and remember, in this function, a is negative 16, b is negative 5, c is 725. Sometimes it's good to write those down so that you don't mess up your values in here. All right, so we have negative b. So the opposite of b is positive 5, plus or minus the square root of b squared. Remember, when you square any number, it'll be positive, so make sure you put that in parentheses. So b squared minus 4 times a times c, all over 2 times negative 16. Okay. All right, so that equals 5 plus or minus. I'm just going to put this radical part in my calculator. Okay, so 25 minus 4 times negative 16 times 725. So just the part underneath the radical is 46,425. And we're going to divide that by negative 32. All right, so we're going to get 2 answers, right? We're going to do 5 plus the square root of that. So 5 plus the square root of that, enter, divided by negative 32. So that gives us negative 6.889519. And then we're going to do 5 minus the square root of that. And we're going to divide that by negative 32. 6.577019. okay? All right, so there's my two answers. And remember, this is a quadratic, so I know that this goes like that, right? But we're up here throwing the stone, so we don't care about the negative time. This problem started when time was 0, so that's not a possible answer. So here's our time, okay, that it hits the ground. Okay, so 6.577 seconds. Okay. Now you think about that, 725 feet off the ground is pretty darn high. It only takes 6.5 seconds to hit the ground. Okay, so obviously it's speeding up quite a bit as it's coming down. So the last question says, what is the velocity of the stone when it hits the ground? Okay, what is the velocity of the stone when it hits the ground? So the velocity function, remember, was negative 32t minus 5. And we know when it hits the ground, this is t. That's the time it hits the ground. So we're going to look for v of 6.577. So we're going to substitute that in. 7 minus 5. And actually, if this is WebWorks, remember, use the whole thing. Okay? So I'm going to put 6.577019196 in my calculator, just because I want to make sure I'm getting the right numbers. Okay, so negative 32 times that whole number, and then minus 5. So I end up with negative 215.4646143, and this is velocity, so this would be feet per second. Okay? Now, negative 215.4646143 feet per second. Remember when this person threw it off of the roof, it was just going negative 5 feet per second. Now, only after 6 seconds, it's already up to this. So I want you to understand how fast this thing is moving, okay? So we're going to do a quick conversion on the calculator just to kind of let you wrap your head around that, because this is important, at least just in real life, why this matters. Okay, so I'm going to do the conversion on the calculator. So I'm going to go to my apps menu, and I'm going to scroll down to scientific tools. Okay, that one. All right, and I am going to do the unit converter, and I'm going to do velocity. Okay. All right, and I'm going to put in my velocity that I got, negative 215.4646143. And this was feet per second, right? That's what we were given. So I'm going to put it over in feet per second and hit enter. All right, so it changed it to scientific notation, so it just moved it to negative 2.15, but here's e to the second, so it's still 215 feet per second. And I want to convert this to, for you guys, miles per hour. Miles per hour. And hit enter. All right, so this same distance, or the same velocity in feet per second, is negative 1.46908. And then don't forget E2, miles per hour. Okay. So that means move that 2 places to the right. Negative 146.908 miles per hour. Okay. I want you to think about that. Okay. Now it's going down, so that's why it's negative. At 146 miles per hour. You know, that's like NASCAR racing speed. That is really, really fast, right? That will do some damage if it hits somebody. So you think about, you know, why when you go to big cities like New York, Los Angeles, Chicago, and all of these skyscrapers that are there. If you get to go to the top of these buildings, it is illegal to throw anything down. Okay, they've done, even a penny, even something that doesn't weigh a lot. A stone is not very heavy, but anything traveling at this speed after 6 seconds, okay, gravity does a lot to all kinds of things. So by gravity pulling down this little stone, in less than 7 seconds, it's going that fast. Okay? So I know it's tempting. I know things out there, let's try this, let's try that. But please, you can kill somebody with something like that. And notice this is only 725 feet. Now you get up much higher than that. Just think about that. Usually things that are dropped that far will break the concrete, right? Will go through the concrete. So please think about that. I just think that's kind of a neat problem to end on, to kind of understand how fast that will change. Okay? All right, so enough on problem 17. That gives you all of the information for antiderivatives, the last section for Calc 1. So hopefully you guys are getting ready for your final and this last test. So work on the homework, work on all of the items we have for Chapter 4. Let me know if you have any questions, okay? All right, good luck on the homework.